Hello everybody, thanks for welcoming me in this meeting, and I want to leave you in any case a presentation so you can exploit the ideas that I have prepared for this meeting. The title could be shifted to Solar Physics Birth in Camera Obscura. Here you have my email, and there is an accompanying article that I have just completed. Thinking to your meeting, I gave to this paper the title Modern View of the Sun, Materials for an Experimental History Before the Telescope, because the Camera Obscura is a key point of the history of astronomy before the telescope. This is the link and the date in which I first put online the first version of this manuscript is June 5, 2025. This is the abstract that I sent to the organizers with the former titles Sunspots, Faculae and Flares in Camera Oscura, which is basically the subject of what I will present. Let me read this abstract with some remark, since Kepler in 1604 and Christoph Scheiner in 1630, the words that they wrote about solar observations, the technique of solar observation in Camera Oscura had marvelous developments. Angelo Secchi in 1859 acknowledged the accuracy obtained by Father Scheiner, German accuracy he wrote, even if the sunspots were contrary to a divine solar nature, as Galileo had to admit in 1612. Today, the observation of the sun made through Miller filters, depends on the pronunciation, does not permit an experience of the dimensionality of the sun in the Camera Obscura. What means, if I observe the telescope with a solar filter, commercial one, the sun does not show a limb darkening unless I get so large magnification, like 200 magnifications. But with a full disk observation, a normal one, the sun is very difficult to show its three-dimensional. Limb darkening and faculae are well visible, and in the case of a flaring white light is discussed in Camera Obscura. Moreover, the conditions required to observe by naked eye the larger sunspot, as in some historical cases, are also investigated. There are observations of sunspots made in Middle Ages that have to be explained from an optical point of view. This is my curriculum that I presented to the organizers. I found some typo errors, so I correct the typo errors here. I was teacher of physics and astronomy at school and at university, and now I'm doing research. I always did it on history of solar astronomy and solar physics. So I want to extend the roots, the meaning of the word solarigraphy to the general writing of the sun, solarigraphy. So drawing sunspots and representing the solar surface along the history. This is very important to understand the solar tradition, the solar physics tradition, and my advice, is important for the recruitment of new young fellows to this wonderful subject. This photo is 11th of June. Now, I used this image as a visual abstract of the paper I just put on the internet, and you are invited to consult. This photo is an image published in 1635, firstly, by the two Jesuits Christoph Scheiner and Athanasius Kircher. Afterwards, Kircher did another publication of this image in 1665. But this image, reproduced on a wooden window in the Vatican museums in 1719, was only visible about 1960. So how it is possible that the two Jesuits, Scheiner and Kircher, drew the sun as it was visible only with instruments of 2 centuries after? This has been realized in camera obscura. Father Secchi said, the great Jesuit of 19th century, said that this drawing contained a lot of fantasy by the drawer, the Jesuit Athanasius Kircher, one of the most knowledgeable men of his epoch, but also with a great fantasy. He could anticipate 2 centuries, even if he had no real proof of what he was saying. But Secchi was an experienced observer, very well experienced observer. But even if you have a great observing time, maybe something it is possible that you have not seen. Let's see probably what was this. So here are a series of images that I titled like Accidental One. In metro station Ottaviano in Rome, the sun passes through the leaves of a platanus and it produces images of the sun that this image is like 30 centimeters of diameter, like my feet, and so it is produced at 30 meters of height. Sometimes it is possible to see a darkening, a limb darkening, and some big sunspot. Was it possible to discover the sunspot before the invention of the telescope? Yes and no. Second accidental image: in my kitchen in the afternoon, the sun passing through the shades of the window produces several pinhole images, and on the most faint ones, so the pinhole is very small, the big sunspots are clearly visible. Third image: an accidental sunrise observed in Austria, 10 of June. The lower images, the images upside down, the lower images corresponds to the sun closest to the houses in front of the window, in the line of sight of the sun. And the higher images is the sun already detached from the house. So see, it is a sequence of sunrise. In a single image, with the shades of the window, you have a sequence, a temporal sequence of the image. As again, on this image, there are some of them in which, if there are big sunspots, they are visible. So sunspots, when they were big, they were observed with accidental devices. Obviously, there are devices built in purpose, like the Great Meridian Line in Rome, in Santa Maria degli Angeli, also known as Clementine Gnomon, the gnomon of Pope Clemens XI. This is an image that I transformed with reverse colors, but it shows the sun arriving to the meridian line, that is this one, with some numbers. I had to do this because the sun is so bright that the solar image is so bright that the other images are underexposed with respect to it. This image is 23 centimeters of diameter. The resolution is enough to see a big sunspot, not a normal one. This is the photo of 12th of June. The sun is already on the Cancer, so it was moving in this position. Only few days difference, and the sun has different height upon the horizon. And so here you see the sun is overexposed with respect to the wonderful map of Cancer made by Francesco Tedeschi in 1702 with marbles, and copied by the famous Celestial Maps of Johannes Bayer, 1603. This is the sunspots of 31 of May that I projected in my home, in my studio. The image is 1 meter and 5 centimeters wide. Is projected by a telescope at 5 meters from the wall. So the sunspots are clearly visible to the teeniest ones, and the umbra and penumbra are clearly visible and distinguishable. So the first image I showed to you, the one of Christoph Scheiner, is somewhat explained by this experience of projecting to this great diameter and reducing the light, the other lights in the room, by closing the window, putting obstacles to the light. Only the telescope could introduce the light into the dark camera, into the camera obscura. And so this is the image on the wall. It is possible to do drawings very accurate of the structure of the spots. The telescope has a diameter of 6 centimeters and a focal length of 40 centimeters. So it's a very small telescope, obviously much better optically speaking with respect to the one used by Christoph Scheiner in 1630 or by Galileo himself 2 decades before, but it gives us an idea of what the best observation made in 1600 could be done. These are other sunspots on 13th of May. This sunspot actually produced an X-class flare the day after, the 14th of May. And so the question was, are the solar flare visible on the solar limb? I want to verify that in order to understand the complex structure of Christoph Scheiner. These could be solar flares and solar faculae. We have to understand if these dark spots are represented as smoke from volcanoes. This work of Christoph Scheiner is dealing with the inner of the Earth, but these are fire in the idea of Christoph Scheiner, but could be flares or only faculae in the modern idea. So these are the faculae observed in camera oscura. Faculae are these structures, whiter than the solar photosphere. These are the sunspots, and this is also another sunspot that produces an X-class flare, so a very bright in X-rays and the H-alpha wave bands flare on the Sun. The last two big flares occur on the Sun are on this region, this one and this one. And so this is the Sun observed by Galileo in 19, 20 and 21 of August 1612. Galileo said that this sunspot was even visible to the naked eye. So, is Galileo the first witness of naked eye sunspots? I mentioned in my paper other sunspots observation with naked eye that were already quoted by Galileo. The observation in 1813 and in 1807 mentioned one in the Historia Francorum and another one in the Historia Vita Caroli of Einhard, the biographer of Charlemagne. So the sunspot could be discovered before Galileo, but in effect they were not discovered. And to remember Galileo affair with the Catholic Church, the famous phrase "Move not, O Sun," that is represented in this mosaic in Santa Maria Maggiore, mosaic of the 5th century, dealing with the book of Joshua. And this is the publication of Athanasius Kircher about the inner of the earth, but according to this model, he transferred this idea to the Sun. And so we have this Sun so carefully drawn with these things that remember very well the spicule that were discovered by Father Secchi 2 centuries later, as well as the flare that were discovered by Richard Carrington in 1859. White light. Are white light flare visible in camera obscura? This is a case. On this spot, I observed one white light flare on 3 June 25, because the faculae are better visible in the limb, like this one. I expected that if a active region was closer to the limb and had a solar flare, that was the good moment to observe it. So I waited until a flare occurred when the Sun was in my camera obscura, and this is the result. This small point was not present before and after, was effectively a C5 in X-ray classes flare occurred on this sunspot, the active region 4105, that is still at the date of 12 of May and 12 of June on the surface of the Sun, on the other side. Kepler missed to recognize sunspot in 1607. This is an image of Jean Tard, published in 1620 with the telescope. Kepler observed the sunspot without telescope, because the telescope was invented in 1609 by Galileo, used for astronomy by Galileo. Other inventors realized the first version but did not use for astronomy with the discoveries that Galileo did. This is an artificial solar eclipse that I used to photograph to study the situation of the sky, the transmission of the atmosphere near the Sun before the observation in Santa Maria degli Angeli. Every day I do that. This was a day in which the sand of Sahara is starting to arrive to the central Italy, and the color of the sky says that. And this is the Sun in camera oscura in my room. The dimension 1.5 meters, 5 centimeters is evident here in the dark, not completely darkened camera. No sunspots are visible in this day, 8th of June, but the solar minimum in 1460 to 1550 was the responsible of the not discovery of the sunspot before the invention of the telescope, because there were already great meridian line with camera oscura operating, the one in Florence and the one in Vatican, but at the same time the sun didn't have sunspot for almost a century, a spurrer minute. Thanks for your kind attention and best wishes for all the Congress.